Alright, hello everyone. So today we're going to find the arc length of the polar function r equals 1 plus sine theta. Theta being greater than or equal to 0 and less than or equal to 2 pi. Alright, so we have an arc length formula, which pretty much says that if we're going from alpha to beta, the arc length is equal to the integral that goes from alpha to beta, square root of r squared plus dr d theta squared, d theta. And our function r1 plus sine theta looks as such. Now we can go ahead and just plug in our limits of integration from 0 to 2 pi in here, and our integral would be 1 plus sine theta squared plus the derivative of r equals 1 plus sine theta, which is cosine theta squared. And we could do that. However, I'm going to rewrite this integral using symmetry, and it'll be more clear in a little bit why we're doing this. I mean, this is a legit, but we're going to run into some trouble just in terms of the making the computation a little more, I guess, decent, you can say, because, yeah, it's going to be a long computation if we keep it this way. Again, it is correct, but it's going to be long, okay? So what I want us to notice is if we trace the curve of r equals 1 plus sine theta, if you begin here at angle 0, which is here, r would equal 1, and then r would increase until it reaches like 2 here at pi over 2. Then it would trace down to pi here. Then it hits 0 at 3 pi over 2. And then from 3 pi over 2 to 2 pi, you get this section. And the section from pi over 2 to 3 pi over 2 multiplied twice gives you the whole arc length, okay? So what I'm going to do here is I'm going to set up my arc length as 2 times the integral that goes from pi over 2 to 3 pi over 2, okay? And this will give us an advantage. So often with these arc length problems, you want to consider symmetry, okay? And it'll be more apparent in just a second. Sorry, and I know I have to, you probably want the answer why, but it's easier for me to explain with these computations. So I'm going to go ahead and take the integrand and simplify that. I'll square 1 plus sine theta, and that gives me 1 plus 2 sine theta plus sine squared theta plus cosine squared theta d theta. Sine squared plus cosine squared is 1 by the Pythagorean identities, and 1 plus 1 is 2. So you have 2 pi integral pi over 2 to 3 pi over 2 square root of 2 plus 2 sine theta d theta. And I'm going to factor the 2 out of the 2 and the 2 plus sign, and then I'm going to take that whole square root of 2 out as such. Plus sine theta d theta, and we're gonna do this. We're gonna go ahead and multiply by a conjugate, pi over 2, 3 pi over 2, and yeah, that's the only way pretty much that I know that you can do this. If this was 1 plus cosine theta, we could use a formula. 1 plus cosine theta equals cosine squared theta over 2, but that's not what we're working with here, so this doesn't work. So I'm going to multiply by the conjugate of square root of 1 plus sine theta. To root 2, and then we're going to have 1 minus sine squared, the inside, all over 1 minus sine theta here. And then this becomes pi over 2, 3 pi over 2. The square root of 1 minus sine squared is the square root of cosine squared theta over 1 minus sine theta. And you get the absolute value of cosine here. Okay, so recall when you take in the square root of something squared, a real number squared, you have the square root of, call it a squared, is equal to the absolute value of a. That's what we're using here. Now, the absolute value is a little bit of a hindrance for us, but we can get rid of it in a second. The function cosine is negative from pi over 2 to 3 pi over 2. So this integral will turn into 2 root 2, 3 pi over 2, pi over 2. And then it's going to be negative cosine theta all over the square root of 1 minus sine theta. Again, this is because of the fact that cosine is less than 0 for theta between 3 pi over 2 and pi over 2. Right, so then we'd go ahead and finish that integration. You can use a u substitution. And if you let u equal 1 minus sine theta, this becomes 2 root 2 integral of 0 to 2 du over square root of u. And this is an improper integral. Please note that. And at the end, this would come out to be 8. Okay, so I'll skip those details. The big advantage here of going from pi over 2 to 3 pi over 2 here is if you had gone a 0 to 2 pi instead, let's say you would have done all the math that I've done, and when you got to this point, 0 to 2 pi, let me just say those were our limits for a second, you would have had to split this up into like 4 or 3 integrals, because cosine takes on different values from 0 to 2 pi. From 0 to pi over 2, it's positive, so the absolute value just turns into just cosine. From pi over 2 to 3 pi over 2, it's negative, so we'd have the negative, and then last but not least, 3 pi over 2 pi, you'd have a positive. So that is the advantage to that. It saves work, okay? Again, it's doable, but it's gonna take you like some time because you'd have to compute like the 3 integrals here, okay? All right, well, thank you very much for your time. Appreciate it.